Right, in today's lesson, we're looking at the cosine law. So by the end of today's lesson, we want to be able to use the cosine law to be able to find the lengths of unknown sides and the measures of unknown angles in a triangle. So this learning goal should seem kind of familiar to it because this is the same kind of thing that we were doing with right angle trigonometry, sine, cosine, tan, and the same thing we were doing with the sine law in the last lesson. So like the sine law, the cosine law works for any triangle that we want, not just right angle triangles like sine, cos, and tan work for. So we are going to look at two different forms of the cosine law. One that helps you, one that you're going to use when you're finding the lengths of unknown sides, and one that you're going to look at when you're trying to find the lengths of, find the measures of angles. All right, the cosine law, as I just said, can be used to find the length of unknown sides or the size of unknown angles in any triangles. It has two forms. Form number one, used when we want to find the length of a side. So here's the cosine law here, and this is exactly what appears on your formula sheet. A squared equals b squared plus c squared minus 2bc cos A. So what does this do here? If we've got a triangle and we want to find the length of side A here, and we know the length of side C and the length of side B, the cosine law tells us that we're going to use the cosine of angle A, i.e. the angle that is across from the side that we're trying to find, and we're going to use the lengths of these two sides that are on either side of that angle. So it relates the length of a side to the angle opposite it, so side A to angle A, and the lengths of the other two sides. You can only use the cosine law when you are given the lengths of two sides and the angle is in between them. Right? Now, this is going to give us the value for a squared. If we want to actually find A, we have to take the square root of all of this stuff. So b squared plus c squared minus 2bc cosine of A. And the order of these things in the cosine law is important. This is always the side that we are trying to find over here. The angle over here is always going to be the angle across from the side that we're trying to find. So let's say angle opposite side we are finding. Okay? And then here and here and here and here are the other two sides. So the sides on either side of the angle. So the side that we're trying to find and the angle always need to match up here and here, and then it's just the other two sides. So let's look at this in action here. We want to find the length of the unknown side in this triangle. So the thing that we are trying to find here is side Y, and they tell us the lengths of side X is 11 inches and side Z is 8 inches. And they give us the size of angle Y, which is 36 degrees. So if we look on our formula sheet, we can copy over the cosine law that we have written there. Square root A equals the square root of b squared plus c squared minus 2bc cosine of A. Now, we don't have A, B, and C in our triangle. We have X, Y, and Z. So our first step here is probably going to replace A, B, and C with the letters that are appropriate to the triangle that we have. What side are we trying to find? We are trying to find side Y. So we're going to, instead of Y, we're going to have A. The angle that we need to use is going to be angle Y because that's the angle that is across from the side that we're trying to find. So this side here and this angle here always have to match up. Then instead of B, we are going to have X, so X squared. Instead of C, we're going to have Z squared, 2xz cos Y. Once we've got this set up, we just need to sub in our numbers. So we are going to have, let's see, side x is 11 inches, so 11 squared. Z is 8 inches, so 8 squared. 2 times 11 times 8 times cosine of angle y. Angle y is 36 degrees. And now we have to evaluate. The trick in evaluating this is to remember that we have to do order of operations. So all of this stuff here is multiplied together. So we want to make sure we do that multiplication before we do the addition and subtraction that we also see under the square root symbol. So let's do that multiplication step first, and at the same time we'll also do our exponents, right? Doing good old order of operations. So exponents, 11 squared is 121, 8 squared is 64, and then we want to minus or subtract 2 times 11 times 8 times cos 36 degrees. Put that all into our calculator. That gets us 142.38. Now that we've done our exponents and our multiplication, we can do our addition and subtraction. 121 plus 64 minus 142.38, 42.61. And then our last step, take the square root, 6.5. And this is going to be in inches. So we should take a moment and just make sure that that answer that we've gotten there makes sense looking at our triangle. We've got y is equal to 6.5 inches. Our other two sides are 8 inches and 11 inches. That certainly seems reasonable. These are all about the same order of magnitude. If we had gotten an answer of, say, 42, we would look at that triangle and say it's too big. So this is kind of a way of figuring out maybe if you've forgotten to take the square root, okay, if you get an answer that is way, way too big. So that's how you use the cosine law to find a side. What about finding an angle? Well, there's a different form, okay? And it's basically the equation that we saw before to find a side, rearranged to solve for that angle, okay? So here it is, cos A equals B squared plus C squared minus A squared over 2BC. And how does this work? Well, if we're trying to find angle A, on the left-hand side. On the right-hand side, we have the lengths of side B, side C, and side A. So we need all three, the lengths of all three sides in our triangle if we're going to use the cosine law to solve for that angle. So I've written this down at the bottom. It relates the size of the angle to the lengths of all three sides. You can use it when you're given the lengths of all three sides. Now, on the formula sheet that you have, in order to help you remember the last step here, I mean, we don't want cosine A, we want actually angle A. So our last step here is always going to be to do the inverse cosine of this big calculation that we see on the right-hand side. Now, the setup of the terms on the right-hand side is important. Notice that we're adding together b squared and c squared, and then we're subtracting a squared. The one that we're subtracting has to match up with the angle that we're trying to find. So if we're trying to find angle A, we're going to be subtracting a squared up in our numerator. And then the other two sides, b and c, appear at the beginning in the numerator and as those two terms down in the denominator. So this is the angle that we're trying to find, matches up with the opposite side, or the side that's opposite in the triangle, okay? And then B, B, and C are just the other two sides. All right, let's see this in action then. We want to find the size of angle D in this triangle. And we look at this, and we've been given 1, 2, 3. We have the lengths of all three sides in our triangle. This is side D, this is side F, and this is side E. So with the lengths of all three sides, we can definitely use the cosine law. So let's just copy that cosine law formula from the previous slide. It was that A is equal to the inverse cos of B squared plus C squared minus A squared, all divided by 2BC. Now, we don't have A, B, and C in this triangle. We have D, E, and F. So we need to match up. We want to, again, rewrite our equation here with the things in the appropriate spots for what we're trying to find. So we are trying to find angle D. So we're going to replace angle A with angle D. And in here, we have to make sure that up in our numerator, we are subtracting D squared. Okay, so it's the angle, the side opposite the angle that we're trying to find. And then B and C here, we can just replace with E and F and E and F, just like that. All right, let's sub in our numbers here. Cos inverse, let's see, side E is 9.6, so 9.6 squared plus 8.7 squared minus 6.8 squared. 2 times side E here is 9.6, and F is 8.7. Okay, and now we just need to evaluate this using our calculator. I would do this calculation in a few steps, just like we did the last one. Right? My first step, I would figure out the numerator and the denominator separately. So 9.6 squared plus 8.7 squared minus 6.8 squared gets me 121.67. Then in the denominator, 2 times 9.6 times 8.7 is going to give me 167.04. And that just helps me do the order of operations, knowing that I have to do the entire numerator and then the entire denominator. Then I'm going to divide those two things. 0.7280, 4 decimal places, because we're solving for an angle here. Doing this calculation here gives us an opportunity to check that we're on the right track. This number here that we get inside the brackets after doing that division always has to be a decimal. Okay, it has to be less than 1. Okay, so I got 0.7280. That looks good. If I'd gotten something like 5 or 27, I would know that I'd done something wrong, and I'd have to go back and check the calculation. All right, inverse cosine of that gets us 43.3 degrees. And yeah, that makes sense. That angle looks like it's about 43.3 degrees. Okay, so that's the cosine law for solving for an angle. So let's do 2 last examples here, just to make sure we've got this down. So we've got 2 triangles here. In each triangle, we want to solve for the unknown. On the left-hand side here, we are asked to solve for angle B. Let's just first check to see if we can use the cosine law. If we're going to use the cosine law to solve for an angle, we need to be given the lengths of all 3 of the sides in our triangle, and we are. A is 16 feet, B is 17 feet, and C is 14 feet. So let's set up our cosine law, and for this one, we can just read one of the versions off of the formula sheet. We are trying to find angle B, so that's going to be the inverse cosine of, we need to be subtracting B squared, so we need A squared plus C squared, and we have to divide by 2 AC. Subbing in our numbers here, 16 squared plus 14 squared minus 17 squared, all divided by 2 times 16 times 14. You might want to pause the video here and try this calculation for yourself, and then double check your answer. I'm going to do it in stages here. I'm going to do the numerator first. I get 163. Denominator, I get 448. Dividing the numerator and the denominator, I get 0.3638, 4 decimal places, and this is less than 1, so looks like I'm on the right track. I do the inverse cosine. 68.7 degrees. Done. All right, let's take a look at the second one over here. And in this one, they're asking us to solve for side D. Well, let's double check, make sure we can use the cosine law. To use the cosine law to solve for a side, we need to know the angle opposite, and we need to know the lengths of the two sides that are on either side of that angle, 10 and 20. So definitely we can use the cosine law here. Side E is 20, side F is 10 meters. All right, let's set up our cosine law, and we're going to copy it off of the formula sheet. And as we do that, though, we're going to replace the A, B, and C that you have on the formula sheet with the sides, with the D, E, and F that we have in this triangle. So we are solving for side D. So we know that the angle that we want at the end here is angle D. We want to do the cosine of angle D. Our other two sides are side E and F, so they're going to be squared and added together, and then we're going to subtract 2 times E times F. Let's sub in our numbers. E is 20, F is 10, 20 and 10 for E and F again, and angle D is 40 degrees. We're going to evaluate this, remembering that we're going to do order of operations and make sure that we do that part of it all in one step. The 20 squared is going to give me 400. The 100 squared, the 10 squared is going to give me 100 rather. And then 2 times 20 times 10 times cos 40 is 306.42. So I've done my exponents and my multiplication. I can do my addition and then my subtraction. 193.58. And then finally, I take the square root and I get 13.91. And this is going to be in meters. So the length of D is 13.1 meters. Just like over here, my angle B, I should put a box around it to indicate that's my final answer. And there we go.